I'm going to talk about pre-hijacked accounts, and this is a joint work with Andrew Paverd from the Microsoft Security Response Center, MSRC in short. And this research was funded by a project grant from MSRC. Some of you may be already familiar with this research because it was covered in some prominent cybersecurity news websites. So I hope I have your attention now. Let's get started. So before I explain what is account pre-hijacking, let me cover some basics on what is account hijacking. So in an account hijacking attack, there is a victim, an online service, and an attacker. The victim owns an account at the service, so the victim can execute the login action by providing the victim's credentials for the service. And after verifying the credentials, the service will authenticate the victim and store a token of authentication, which is a cookie, at the victim's device. Let's talk about the attacker. The attacker is an adversary whose goal is to obtain access to the victim's account at the service. And in order to achieve this goal, the attacker leverages different adversarial tactics. For instance, the attacker can try to mount a phishing attack on the victim and hope to obtain the victim's credentials for the service. Or the attacker can directly target the service and try to exploit some vulnerabilities and obtain sensitive information such as the victim's cookie and try to leverage it. So account hijacking attacks are well known and well studied. So there has been a lot of research on the various adversarial tactics and defenses for account hijacking attacks. But this is not the case with account pre-hijacking attacks, and it is a very understudied subject. So what is account pre-hijacking? So in an account pre-hijacking attack, an attacker hacks the online account of the victim even before it is created. So some of you may be wondering, does it make sense to hack an account even before the victim creates it? We'll see the details in the following slides. But before I proceed, I want to explain the assumptions we make about the victim and the attacker. So the first assumption is that the victim does not have an account at the service at the beginning of the attack. The second assumption is that the victim ignores the notifications sent by the services where they don't have an account. And we assume that the attacker knows the identifier, for instance, the email address and other basic details of the victim for creating an account. For some account pre-hijacking attacks, we need the capability for the attacker to make the victim visit a URL. This is a realistic assumption because it can be achieved through, let's say, clickbaiting. We also make other basic assumptions like the victim has security knowledge and they cannot be phished, and the service is secured with all the updates on the libraries and everything. So let's see our first example of account pre-hijacking attack. So I will show the timeline on the left-hand side. So in the first step, the attacker creates an account with the victim's identifier. So to do this, the attacker fills a sign-up form. So the attacker provides the victim's email address, which is a Gmail address in this example. And the attacker will provide a password and the victim's name. And an account will be created and a cookie will be stored in the attacker's device. The attacker then waits. In fact, the attacker waits until the victim tries to create an account with the same identifier. So the victim will fill the sign-up form and provide the same email address that was provided by the attacker. And a different password will be provided, of course. And the service will complain that an account already exists with the same email address. So the victim is confused here because they don't remember creating an account. So they may think that they had created an account in the past and they forgot about it, or they may assume that this is because of the acquisition of this service by another service where the victim has an account. So the victim will not be able to log into this account since the attacker chose the password for this account. So the victim will initiate a password reset for this account because the victim owns the email address, right? So the victim will provide the email address and a password reset link will be sent to the email address. And using the password reset link, the victim will change the password. So the account's password has been changed and the victim will log into the account and start using the account. What can go wrong here? Let me explain the first case study, which is LinkedIn. So this is the password change form of LinkedIn that will be used by the victim during password reset. And as you can see, there is a checkbox that asks the victim whether they want to invalidate all the past sessions after the password change. And this checkbox is not checked by default. So if the victim provides the new password without actually checking this box, what can happen is that in the first step, when the attacker created the account, a cookie was stored in the attacker's browser. So as long as the attacker keeps this session active, the cookie is also valid. So in step 5, when the victim logs in and starts using the account, let's say the victim uploads a sensitive file called secret.txt. Later, the attacker can view this file by providing the attacker's cookie and obtain access to this secret file. This attack is called unexpired session attack. So how did LinkedIn fix this? So when we reported this attack to LinkedIn, they now check this box by default. So let's see our second example. So the first step is the same. The attacker creates an account by filling the sign-up form with the victim's email address. But the second step is different. In modern websites, the victim has the possibility to create accounts through single sign-on. So since the victim uses a Gmail account, they can create an account through Google single sign-on. So the victim will opt for this option. So the victim will provide the access token to the service, and the service will contact the Google Identity Service for obtaining the details for creating the account. So the IDP service will provide the victim's information, such as the email address and name. And this is an interesting point because at this moment, the service is confused because there is already an unverified account with the same email address. So what can go wrong? Let me explain the second case study, which is Zoom. So Zoom used to silently merge the attacker-created account and the victim's account. So how silent are we talking about? So this is the user interface of Zoom when the account merging is happening. And as you can see, there is no mention of the keyword account merging. In fact, there is a button that says create account. So the victim may think that they are actually creating an account, but in reality, they are authenticating to an attacker-controlled account. So the victim will think that they created the account and starts using the account, but the attacker maintains access to this account. So this attack is called the classic federated merge attack. How did Zoom fix this? When we reported this issue to Zoom, now they implement strict identifier verification. So whenever you say that you own an email address, you need to provide proof that you own the email address before Zoom actually associates an account with that email address. Let's see another example. So in the previous two examples, we saw that the attacker creates an account with the victim's email address by filling the sign-up form. So in the second example, we saw that it's also possible to create an account through single sign-on. So is it possible for the attacker to create an account with the victim's email address through Google single sign-on? In fact, it is possible, and this 2018 USENIX paper talks about this threat model. But they make the assumption that the attacker has already compromised the victim's Google account. But this is a very powerful attacker, and we did not want to consider such a powerful attacker. So we explored what are the other options the attacker has. And that's when we identified the custom single sign-on option. Let me explain this with Zoom as the case study. So this is the login page of Zoom, and where you have the traditional single sign-on, and you have the custom single sign-on. And if you click on the custom single sign-on option, you will be taken to a page where you have to provide your company's endpoint details. And once you provide the details, you will be taken to your company's SSO endpoint. And if you provide the login information, you will be redirected to a Zoom account, which is managed by your company. So what this means is that anyone can host an IDP and configure it to work with Zoom or a service that supports custom single sign-on. So in this attack, the attacker is going to exploit this feature. So the attacker will create an identity provider and configure it to work with the service. And then the attacker will create a user at the attacker's IDP with the victim's email address. And the attacker will initiate the single sign-on. And in the end, an account will be created with the victim's email address. So later, when the victim tries to create an account with the same email address, the accounts get merged, but the victim thinks that they actually created the account. And attacker maintains access to this account. So this attack is called non-verifying IDP attack. So we saw 3 different account pre-hijacking attacks. In fact, we identified 2 more, but due to the lack of time, I cannot get into the details. But interested folks can refer to our paper or read a short MSRC blog article. So after we discovered 5 different account pre-hijacking attacks, we wanted to measure the prevalence of these attacks on the top most popular websites. So we chose the Alexa global top websites, and we focused on the top 150 of them. So out of these 150, 136 websites supported account creation, and out of them, we tested 75 websites, and some of them were skipped because they were duplicates, like google.com and google.co.in. So we just had to test one website. And some of them were like unreachable and some of them had high requirements. So out of these 75 websites, surprisingly 35 of them were vulnerable to account pre-hijacking attacks, and they include prominent websites like Zoom, LinkedIn, Dropbox, and Instagram. We responsibly disclosed all the vulnerabilities to the affected vendors, and some of them acknowledged our findings and fixed the issues and paid us bug bounties. So let's talk about the countermeasures. So the important countermeasure here is about strict identifier verification. So whenever someone creates an account or claims that they own an identifier, the service should verify it before actually linking the identifier to the account. There are additional defense in depth strategies like after every password reset, the service should sign out of past sessions. And whenever there is account merging, the user should be asked for consent, and unverified account pruning, which means deleting unverified accounts after a certain time, and multi-factor authentication so that the victim will be notified every time the attacker logs in. There are additional defense in depth strategies explained in the paper. You can refer to the paper for more details. So to conclude, we focused on the account creation process of websites, which is widely understudied. And we identified 5 different account pre-hijacking attacks. We tested 75 top websites for account pre-hijacking, and out of them, 35 were vulnerable, including prominent ones. We responsibly disclosed all the vulnerabilities to the vendors, and we also present different countermeasures. So that's all. I can answer some questions if you have some.